Hello, welcome to your sixth webinar. In this webinar, we will go through two different topics. At the start, we will talk about sentiment analysis, and then we will go deep into topic modeling. So let's talk more about what is sentiment analysis. Sentiment analysis means that we will get any type of text, and we want to see what is the emotion in it. Is it positive? Is it negative? Is it neutral? And that is the this sentiment analysis can solve a lot of problems, especially if you're a business owner and you have a lot of products and you're selling it online. You want to know what is the statistics of that product. Are people liking it? They don't like it? And this sentiment analysis can solve all of it. And there's also a lot of other application that you can use in marketing. So the dataset that we are using is called Large Movie Review Dataset from Stanford. You can just click on it and click on here, and you will download the whole dataset. So that being said, let's dive into our codes and start writing it. So at the very start, we want to write a function that will load our dataset. So we can call it load dataset. And we can also have a parameter called data_dir, which is directory. I will define it here. Okay. So at the start, we want to initialize a dictionary. That in this dictionary later on we will add all of our X data and also Y data, which is input and output. So let's say initializing a dictionary for X data and Y data. So X data equal to empty dictionary. Also Y data is equal to empty dictionary as well. Now we want to iterate through the two strings called train and test, because we also want to have our training set and also test set. So iterating through the train and test. For train or test, we will have an empty list, not empty list, a list of train and test. And inside this loop, we also want to initialize another set of dictionaries, which we will do it for each of these X data and Y data, and inside of it, which is training and test set. So let's say initializing an empty dictionary for the train and test, which it will be just this, and in here you will have a list, which in here is going to be train or test, which is X data. The first loop is going to be about training, the second loop is going to be for testing. So we will initialize it with the empty dictionary. We will do the same thing for the Y data. Okay, now we want to have our second loop, which is similar to this, but instead of iterating through train or test, we want to iterate through positive or negative, which is going to be our labels. So let's say iterating through positive or negative. Or positive or negative in a list of two string called positive and also negative. Okay, in here again we want to initialize empty list for each of our sentiments. At the very start we did dictionaries, which it was for X data and Y data. Then we did empty dictionary for our training or test. In here we want to do the same thing, but initializing it with the list, which is going to be for our sentiments. So let's say initializing an empty list for each sentiment. Say X data, train or test, also positive or negative. We will initialize it with empty list. We will do the same thing for our Y data, which is train or test, positive or negative with empty list. Now we want to get all of the names of our text in our folder, because if you go to the folder you will see that there's a massive amount of text that we want to have name of each of them. It's always better to, before loading your data, to actually take a look at your data to see in what format it is, how it is, so you can actually do this step so much easier. So let's say get the name of all texts in our folder. File names. In here we use globe, so let's import it. Globe.globe. Also use import os. We say os.path.join, which it will just add some slashes in between parameters that we give. The first one is data dir that we define in here. The second one is train or test. And the third one is positive or negative. And at the end we will just put this. So we want to select all of the files. The last one is very important to put. So say text. Now we want to have our very last loop, which we will iterate through the file names that we got here. Let's say iterate through the file names for ifile in file names. So after iterating through each of the file, we want to open them, and after the appending to our dictionaries. So let's first open the file, the text file, and we can do it with, let's say, open ifile as ifile. Now we will assign values to our dictionary from that file. So we'll say xdata, which is this. Then we want to say train or test, which is this. Then we want to say positive or negative, which is this. Then we want to append the I file. Also we would do the same thing for our y data, say train or test, positive or negative, append positive or negative. Now it is done. Now with this function we can load our dataset. Let's say come back to this, say return x data, y data. Okay, let's see what's the problem. Okay. Now we have our function. Let's actually load our data set. So we can say x data y data equal to the load data. And since we already defined the directory, we don't need to actually code anything. Now it might take a while until load the data set. So until it does, we can actually write down some, print out the shapes of x data and y data. So we can say training set. Let's go to another line and say this amount of positive and this amount of negative format, which is going to be length of our x data train positive, and this one, the amount of negative one, is going to be length of x data, again train, but this time we will get the negative one. Now let's do the same thing for our test set. So let's just copy paste it, say test, and in here we would say, instead of train test, and test. So as you can see, it is absolutely equally distributed, the amount of positive and negatives. So it's very great. Now we want to split our data set into training and test set, because as you can see in here, we have to define x data train positive. So we just want to have all of it in one place, and also it is shuffled already. So what we want to get in here is to have a x train, y train, also x test, y test. We can get the x train by saying x data train positive plus the same thing but for the negative sentences. Negative. Now let's get our y train, which is in here. We just have to say y data and y data. So far we got our x train and y train. Let's do the same thing for x test and y test. We just copy paste for doing it more speedy. In here we will just say test and test. Let's copy paste again. Test, test. Now we got our x train, y train, x test and y test. However, notice that when we sum this up, it is not shuffled already, and it might make some problems when we want to build our model. So it's always better to actually shuffle it. For shuffling, we will use sklearn. You can say sklearn that utils import shuffle. Okay, great. X train, y train, shuffle, x train, y train. As simple as that. We just put shuffle for x train and y train, and it will do the job. X test, y test, shuffle, x test, y test. Okay, now we have our shuffle data, and since this is almost a large data set, and it might take a lot of speed. So now we just want to get a small subset of it, so we can do our stuff more speedy, and at the end, if everything goes well, we can actually use all of the data set. So let's say X train, Y train. We want to get the first 4,000. Y train, first 4,000. We want to do the same thing for test, but in here we will get the first 1,000 instead of 4,000. Y train, Y test, 1,000. Okay, now we have successfully loaded our data set. We got our actual training set and test set, we shuffled it, and also we got the small subset for speedy reasons. Now, like any part of neural network, we have to apply pre-processing, which in text we will do 6 steps. We first lowercase the text, then we will remove the punctuation, then convert the tokens, and then remove the stop words. And at the very end, we would apply stemmer and lemmatizer. Okay, before actually writing our function, let's import some libraries. Let's first import the NumPy and then regular expression. Also, let's import some packages from NLTK, like nltk.tokenize, word tokenizer, and also we want to import our stop words, corpus, import stop words. Also we want to import for our stemmer and lemmatizer. We can say nltk.stem import porter stemmer and also wordnet lemmatizer. And also we want to import beautiful soup because there are some HTML tags that we want to delete all of them. Beautiful soup made our job so much easier. I guess that's it. Now let's start by writing our function. LTK, okay, tokenize. Okay, great. Now let's start by writing our function. Let's call it preprocess text, which in here we will get a text as our parameter. And at the very start we want to remove all of the HTML tags, which we will use beautiful soup. Beautiful soup. We want to apply this to our text, and also let's define HTML5 lib for deleting all of the HTML tags. And it's also important you write down get text because we only want to get the text of it, as there's going to be other tags from JavaScript that we want to delete all of it. And also there's going to be some empty spaces, and also we want to get rid of that as well, which for doing that you can just say dot strip. Okay, now we will lowercase the text, which it is as simple as saying text.lower. Then we will remove all of the punctuation, like question mark, dot, and we use regular expression for it, which is re.sub. In here we will say that keep everything that is lowercase, uppercase, and also keep all of the numbers. If there was anything other than that, then replace it with the empty strings. And also at the end you have to say where you want to apply it, which is our text. Then after this step we have to convert our text to tokens, which we already imported a package from our NLTK, word tokenize. Let's call this tokens is equal to word tokenize, and we will apply this into our text. After tokenization, we want to remove all of the stop words, which stop words are words that appearing a lot, and it's better to remove it for having a better result. Stop words. Let's also call this tokens as well. In here we will make an empty string, empty brackets, because we want to have a list at the end. Let's say for I token in tokens, which we will iterate through tokens, and we want to say if I token is not in stop words, which we imported from NLTK. Stop words, that words English. It's important you specify English because NLTK also have stop words for other languages as well. And at the end we will just say a token. Okay, great. Now we remove all of the stop words. The last step is to apply stemmer and lemmatizer. So let's start by stemmer. Stemmed. We will iterate through our tokens, and we want to apply stemmer to each token. Now lastly, let's apply the lemmatizer. Also in here we will do the same thing. We will iterate through each of the tokens and we will apply the lemmatizer. But also remember the limit for lemmatizing. If you want to apply for both noun and verbs, you have to apply separately. You cannot do it in just one line. So first let's iterate through each of the tokens. Which we will apply word.net lemmatizer to each of the tokens. And also in here you have to specify the part of speech, which at the start we applied for our nouns. Then we will copy paste it, but this time we will apply it to our verb. And you can just return it. Now our pre-processing function is finished. We can start by applying it to our training set and also test it. And since the training test is a list of lists, so that is why we have to iterate through each of the lists inside the xtrain. Say pre-process. Let's do the same thing for our test set, which is xtest. Okay, see what is the problem. Okay, great. Now it is applying the pre-processing to our data set. It might take a while, so until it gets totally finished, we can do the rest of the coding. So next we want to get all of the data set in one place, which is xtrain and test set. It is important because when we want to create a dictionary for our word to ID and also to word, we need to first get a vocabulary. So before that, let's just get a total data set. It is as simple as just adding them because they're list xtest. Now, as I said, we want to get all of our vocabularies, which is all of the unique words in our dataset. For getting the unique word, we use numpy.unique. And inside of it, we want to have a list, which at the start we will iterate through sublists inside our total dataset. And also we want to iterate again inside the sublists. Let's call it item, for item in sublist. And we want to get the item. Since this is the list of lists, we want to get item inside each of this list of lists. So now we have our vocabularies, unique vocabularies. We want to get our word to ID dictionary and also ID to word dictionary. Word to ID to a dictionary. Can iterate to index and also iTokens. In enumerate all of the unique words. And in here we can just say simply iToken, map it to index. Very simple, right? Now let's do the ID to word, which is literally the same thing as a word to ID. The only difference is to replace the place of iToken and index, which we will map indexes to iToken. So let's see if everything okay. Okay, seems about right. Now we want to, in our training set, since now we have our pre-processed version, we want to map each of the words to an ID, because we cannot work with text. We have to work with IDs and values. So the first thing, we will map all of the words in our training set to its corresponding ID. Let's say for index sublist, in enumerate xtrain, and we'll say xtrain, each index is equal to a list, and also we want to map it. So lambda x is equal to word to ID that we have just created it. We want to map the x, and also we want to apply this to our sublist, and that is it. With this simple loop, we will map each of the words in our training set to its corresponding ID. Now we want to do the same thing for our test set, which we'll just change some few things. In here, instead of saying xtrain, we'll say xtest. Also in here. I guess that's it. Now we map all of our words in our trainings and also test set to its words. Next, what we want to do, we want to pad the sequence. As you know, like, each of the sentences have a different length, which it doesn't work so well for us, and we want to have a same length. So for sentences that are small, we will add a 0 padding, and for those which are larger, we will just eliminate it. And for this, we use a Keras library for padding. We say from keras.preprocessing import sequence. Let me see if I wrote it wrong. Pre-processing. Okay, sounds right. Now let's add the padding. So in here we can define max words, which is if it's more than that, then we will ignore the after the max word. If it's less than that, then we will just add a zero padding. So let's define 500. First we will apply this to our training set. We will say sequence dot pad sequence, again xstring, and also we have to define the max len, which we defined it already for 500. We will do the same thing for our x test. And now we have our padding. Lastly, we want to convert our labels into 0 and 1. Since if you look at it, our labels are positive and negative, and we want that those be also numbers. So we can actually define a function for it. We can call it string to int, which we will get label, and if the label is equal to positive, we will return 1, else, which is if it's negative, we will return 0. And we will map this function to each of our labels in training set and also test set. So map the name of this function, which we will apply this to our white chain. So let's do the same thing for our test set. And that is it. Now we pre-process all of our data set. Now we are ready to go to creating a model. So before actually creating the model, let's import the necessary libraries that we are going to use. So at the very start, we will import sequential from the keras.models. Sequential, and then we will say from keras.layers, we will first import the embedding, then we will import the LSTM and dense, and also and that is it. And also we will import from keras.callbacks, import the model checkout, which we will save the at each epoch we will save the best model. So in here we can define some hyperparameters. So this is something that later you can also change it a little bit for further improving the model. In here we will define the embedding size of 32, the LSTM size of 100, byte size of 128, and also we will have in total number of 10 epochs. Also, let's add one thing else called vocabulary size, which is going to be length of all unique words. So let's start creating the model. Like always, we will start by sequential. Then we will add, after the sequential, we'll add the embedding to this with the vocabulary size, embedding size, and also we will have a input length, which is our max words that we define it here. So after embedding, we will add LSTM with total number of units of LSTM units that we define it here for 100. Then at the very end we will have our output, which is dense, number of units 1, and also we are going to have a activation of sigmoid. Now let's compile the model by writing down model.compile. So in here we have to define a loss function in which we will use a binary cross entropy. And also for our optimizer we define Adam, and we use metrics of accuracy. At the very end, let's get the summary of our model. Okay, this is our model. And before training it, we have to define a checkpointer for saving our model at each epoch if it have an improvement. We call this checkpointer, and we'll say model checkpointer, which we imported from keras.callbacks, and we'll say file path. For me is saved models, and I will call it weights.best.sentiment analysis, say hdf5, and also we say verbosa1, and also save best only. We don't want to save at each epoch. We want to save it at each epoch if it was any improvement. So we are ready for training. We say model.fit, say xtrain, ytrain. Also we will define a validation data, which is xtest and ytest. And also let's define batch size, which we already defined in our hyperparameters. Epochs, again we define this as well. Callbacks for saving the model. We put this into a list, and at the very end we'll define a verbosa1. So until it's training, we can write down the rest of the function, and when it finished we will run them. So after fitting them, after training the model, what we want to do is to actually evaluate it on some dataset that it never saw it. So we can call this scores model.evaluate, which we want to evaluate on our training test set and xtest and ytest, and we call the verbosa1 0. And let's also print out the result. Test set accuracy format of scores, which is a list. We want the second item in it, and also we will multiply by 100 so we can get the actual accuracy in percentage. So we'll run this. Whenever this training finishes, it will automatically run, and Lastly, we want to write the prediction function, which in here we will give any type of unseen text, and at the end we want to see if the given text is positive or negative. So let's call this function text to predict. And as a parameter we get an unseen text. So at the very start we will pre-process this unseen text. Unseen text, pre-process text. We'll apply it to this unseen text, and then we want to convert the words to IDs using the dictionary that we already created. You can see unseen text is equal to list of mapping of X, which we use the dictionary we already defined, word to ID, and we will get each of the vocabularies from our text, and we will apply this to our unseen text. Now we pre-process our unseen text and also we convert it to IDs. What we want to do next is to actually do the padding. So if it's less than 500 we will add zeros. If it's more than 500 we will delete the extras. So let's say pad sequences unseen text sequence dot pad sequences, which we will apply this to unseen but inside the list, and also max word that we already defined it as 500. Now that we have our padding, it's time for prediction. So let's say get the prediction, which this prediction is going to be a number between 0 and 1. Say model.predict. We will apply it to our unseen text. So this is going to be list of lists. We will get the first one and also first one, and then we will multiply it 100 so we can get the actual percentage. So now this is the time to actually print out the text to see if the given sentence is negative or given sentence is positive. So since this prediction is a number between 0 to 1, we will say if this number was bigger than 0.5 is positive, if it was less than 0.5 it's negative. So print the result. In here we use a if statement. We will say if prediction is more than 0.5, print out the given sentence is positive. And also we want to say if the prediction it was less than 0.5, we want to print out that the given sentence is negative. So now this is our prediction function. We are ready to predict every unseen text. So as you can see, there's already two unseen text has been provided. The first one is the movie is absolutely terrible. It's not something I would suggest. So our model should correctly predict this as a negative sentence. And for our second sentence, which is the movie is absolutely great, can't wait to watch it again. And our model should correctly predict that this is a positive text. So let's apply the function to this unseen text, run it. We want to also do the same thing for this positive text. So now let's take it back and let's see how the training is doing. So now I would pass forward it, so we will see the result. Okay, the training now finished, and as you can see, we got around 80% accuracy in our test set. And also for a prediction, it correctly predict that this is a negative sentence and also this is positive. And of course, if you use, we just use a subset of the whole data. And if you use the whole data set and also work around a little bit with the model and also a little bit with the hyperparameters, you can make this accuracy so much higher. And also, if you're interested for learning more, you can go to these resources. Okay, let's go to the second part of this Jupyter Notebook, which is about topic modeling. What is topic modeling? It is that we want to give a text to our model and we want to predict what is the topic of that text. This is very useful, for example, if you have a lot of articles and you want to give title to it. And this model can automatically give title to every single text that you give to it. And more specifically, we use a model called latent directed allocation, or LDA in short. So let's start by loading the data set. But before that, let's import the libraries that we needed, which is NumPy and also pandas. And also we want to give a random seed of specific numbers, so my result and your result be the same. We say 10, 10, 1. Okay, now let's load the data set. Let's say pd.read CSV. So in here, the path to our data set is this ABC News. Okay, this is the data set that got gathered over the 15 years period, and the source is Australian news called ABC. So let's take a look at the head. As you can see, we have two columns here. One published date, which is over the 15 years period, and also we have a headline text, which is the text of each single news. So since in here we don't really care about published date and it cannot do anything for us, so we will just delete it. It's called these documents, and we will get the data that only has this column, and we don't care about the rest of the columns. Also, let's get the first 19,000 rows, and the reason why we want to do this is because to give more speed to our coding, and at the end, if everything went well, then you can actually consider every single rows. But for now, we just only consider a small subset, which it can do more good than doing bad. So let's call this documents again, and we will get only first 90,000. And also we want to add another column called index. So we can do this by calling a new column called index, and we want to get the index of documents. Let's take a look at also documents. Okay, as you can see, we deleted one column, we added index, and also we have only 90,000. Let's also print it. Total number of documents, which is length of this document we already wrote. So as you can see, 90,000. So the second part is pre-processing the text. And since we did this already in our first part, we can just copy paste it. Copy paste the libraries. And also copy paste the pre-processing function itself. And since in here we really don't care about HTML tags because we don't have it, so we can delete this line, but the rest of the line is the same. And also you have to make sure that you have already downloaded the WordNet dataset. So we can say WordNet portal TK. Okay. Now let's apply this preprocessing function to our column, or more specifically to the headline text column. So we can say preprocessed documents is equal to documents headline text, and we will say map, which it will apply this function to each of the rows in that specific column that we set. So we want to apply the preprocessed text function. Okay, now it might take a while, so we will just continue with the coding, and whenever it got finished we will come back and take a look at it. Also, let's write down the head, the first 10 items, so we can watch it later. So after we pre-processed our data, the next step is to apply feature extraction. In here we use a backup word, which we will get all of the unique vocabularies, and we will count it, like in each sentence how much of that unique vocabulary is in it. So in here the only library we need is a Gensim, and we want to make a dictionary of the word2IDs, which we can do this either simple just by hard coding, or we can also use a library as well. So we call this dictionary equal to Gensim. We say corpora dictionary, and we will apply this preprocessed documents, which it will get all of the words and their corresponding integer ID. And also, let's say we want to print out the first 10 item in our dictionary, which is word and their corresponding integers. Let's initialize the count with zeros and iterate through our dictionary items, which it will give us a key and value at each loop. Dictionary dot iter items, and in here we can print out the key and also the value, and we will add 1 to our count. And since we want only the first 10 item, then we want to break if the count got 10 or more than 10. So let's say if count is equal to 10, then just break the loop, and that is it. And this this will give us the first 10 items in our dictionary. More on later, we will exactly look at it until this pre-processing gets finished, because it will take a while. So now we want to delete very rare and also very common words. And again, we can say dictionary dot filter extremes. The first parameter is number of blow, which we will specify 15. What does this mean? Is that we want to remove all of the words that appear less than 15 times. So, okay. As you can see, this is our preprocessed text. This is the first line, second line. We have our token, which all of them got preprocessed. And also this is the first item in our dictionary, in our bag of word dictionary. So let's continue this. So we said we want to remove all of the words that appear less than 15 times. And also there's another parameter called number above, which this is a percentage. We'll specify 10%. It means that words that appear in more than 10%, we want to remove them. And lastly, there is keep n, which we will specify around 100,000, which this is just keeping the most frequent tokens. So now we already deleted the very rare and common words. Now we can start applying the bag of word for each of our documents. We can say bag of word corpus, and we would have a list and in this list we will iterate through each document in our preprocessed documents. And for each of the documents that we get, we want to apply the bag of word, which is say dictionary document to bag of word, and we will just apply this doc to it. Let's also print out the sample bag of word, of our sample document. Bag of word corpus, for example, let's say 10th option. Like if you look at it, this is our words integers, and also this is the number of occurrences. Now we got our bag of word. Now let's say we want to print out the bag of word for our sample document. Say bag of word 10, which is the 10 item in our bag of word corpus, this item. And we want to iterate through our bag of word. Range length bag of word 10. And we want to print out the word with word ID of repeated these times, which the first one is going to be dictionary bag of word 10, and it's going to be I in here, which is the range, and also it's going to be the first item, the actual integer of that word, and the second item So the second item is going to be bag of words 10 integer first, and the third and last one is going to be bag of word 10 I and 1. As you can see, we can exactly see the word Iraq with the word idea 40 repeated one time. So this is a word called Iraq and the appearance is one time. The word Australia is 43 and it appeared one time, and so on. And also, since with bag of word we have a limitation, we want to do apply TF-IDF to our bag of word. So let's import the libraries for it, which from Jensen we will import the corporal and also models, and we would also import the pprint, which is just make the printing more beautiful. And now let's initialize our TF-IDF, which will say models.tfidf. It has a parameter called corpus, which we will make it equal to bag of word corpus, which is here. This is bag of word. Okay. Now let's apply this TF-IDF to the whole corpus and change them. We call this TF-IDF corpus, and we say TF-IDF bag of word corpus. Now let's print out the first item in our TF-IDF. We will say first item in the TF-IDF is equal to TF-IDF corpus 0. So this is very similar to bag of words, but it will divide it to its document frequency. So now let's preview the TF-IDF for the first document. We can iterate through the TF-IDF corpus. Let's say for doc in TF-IDF corpus, we will say pprint doc, and we will break the loop since we only want the first item. And here you go. Now, since we already applied the pre-processing, also we did the feature extraction, the next step is to make a model for it, which in here we will use a LDA. So let's start by defining a LDA model. We'll say a LDA model TF-IDF is equal to Jensen models LDA multi-core. And the first item is corpus, which we will use the TF-IDF corpus, and also the next item is number of topics, which we can use 10. We want 10 topics for each of the documents, and also ID to word, which is a dictionary. We already created it. And we use a passes of 2 and workers of 2. Now let's explore each of the words in our topic and its weight. We will iterate through our LDA model TF-IDF for index topic LDA model that print topics and in here we will for each loop we will print out the corresponding topic, and also let's go to the next line and print out the words as well. We'll say that format. The first one is our index and the second item is our topic. And also let's again go to the another line. So as you can see, we went to our LDA model TF-IDF and print out all of the topics and its words. So let's now actually predict some unseen text that our LDA model never saw it. Like always, when we get an unseen document or unseen text, we have to apply the pre-processing to it. You can say pre-processed text. Pre-processed text, we will apply it to this unseen document. Let's take a look at it. Also, let's print out the result of pre-processing. Pre-processed text is equal to pre-processed text here. Okay, this is the tokens. Everything has, all of the pre-processing step has been applied to it. And now let's create a bag of words. Say bag of word vector dictionary doc to bag of word. And in here we will apply this process text. Let's now print out the result. We'll say bag of words for given text. So this is our bag of word, which this is the integer of our word. Like big is 56, plan is 57, and also this second item in our tuple is the occurrences, which all of them has been appear one time. Now let's actually check out the topics. We will iterate through, let's say, index score. Also, we want to sort it. The LDA model TF-IDF. We will get a bag of word vector. And also, this is for the sorting. The key is lambda tuple -1 is multiplied by tuple in here, and we will get the second item of it. So let's go inside the loop. Okay, let's go inside the loop and print out the score is equal to this, which we will get only the second item after the dot, and we'll say topic, which is equal to this, and we will write down format. We say a score multiplied by 100. Let's also write down a percentage 100, and for the second item excuse me, for the second item we will say LDA model TF-IDF print topic, say top okay index, also top n of 3, which we will get only 3 topics for any given document. So As you can see, for this unseen document, we got it with 85% accuracy. We got water and government. I really not sure what is this. And as you can see, we got document for this unseen text. And that is it with the topic modeling. And if you're interested with more learning, you can check out these resources. Thank you very much, and see you on the next webinar. Thank you.